Welcome to an example in which we are taking a complex number, minus 1 minus 5i, to a big power. And we want to give our answer in a plus bi form. So how are we going to do this? Well, it would be difficult, really difficult, to write 6 of these, right? To go minus 1 minus 5i, minus 1 minus 5i, minus 1 minus 5i, etc. 6 of them. And then start foiling. Boom, 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 boom. 1 plus 5i plus 5i plus 25i squared. And then you got to foil with the next one. And then that's only 3 of them. And then, you know, it would just get crazy, crazy messy. Crazy messy. To do it, that would be true, though. I mean, you could do that, right? Here, I could do maybe one more step if you want to see it. 25i squared. Then you got to foil that with minus 1 minus 5i. And that actually, that's minus 25, right? Because I squared is negative 1, so that'd be minus 25. 1 minus 25, that'd be negative 24 plus 10i. And you got to multiply that by minus 1 minus 5i. And then you got to foil those guys, and you get plus 24 plus 120i minus 10i minus 50i squared. That's just 3 of them. That's just 3 of them. And you'd have to, well, I almost want to finish it now. This would be 24 plus 110i plus 50, right? Because minus 50i squared is negative 1 again. So 24 and 50 is 74 plus 110i. Okay, that's 3 of them. That's just the third power, right? I've only done 3 of them so far. I have 3 more to go. So it would just get really, really tedious. You could do it that way. Well, you know what I almost want to do? Let me show you a trick. If that's 3 of them, then we could just do 3 more of them, and that would be 6 of them. So that's 6 of them right there, right? Because that's 3 of them, and that's 3 of them. If we repeat it again, then we just foil this. Those are big numbers. It's getting really big. This is not how you're supposed to do it, by the way. I'm just showing you another terrible way. 5476 plus, what is 74 times 110? Plus 8140i plus, and that'd be the same thing again, 8140i plus, what's 110 times itself? 12,100i squared. So that'd be 5476 plus, add these two together, it'd be 16,280i, and then this is going to be negative 1 again. I squared is negative 1, negative 12,100, so 5,476 minus 12,100. What do we get? We get minus 6624 plus 16,280i. I think that's the answer. Now, that was kind of a pain. We've got a way easier way. So that would be what you had. And I noticed a trick there that saved us a lot of time. I did 3 of them, and then I said, well, if that's 3 of them, do the other 3, and 3 and 3 is 6. And I think that's right. But anyway, that's not how you do the problem. Let's instead try it the right way. So let me come down here and do it right. So let's try again. And here's a quicker way. So that's a long way we'd like to avoid. So what is the quick way, the short way? Well, look at the notes. If you look on the notes, here's the Chapter 10, 3, 4, and 5, Complex Numbers, Polar Form notes at the top of Module 5. Go all the way down here to number 11. Power of a complex, see it down there? Power of a complex number in rectangular form. So here, I copied it down here for you. So there it is. Power of a complex number in rectangular form. What do you do? Because that's what we have, rectangular. We don't have polar form right now, right? We're starting with, this is rectangular form. So what do? Change rectangular form to polar form. And there's instructions for that in number 7 above, it says. And then power the polar form according to number 10 above, and then change it back to rectangular. So we go rectangular to polar, power the polar, back to rectangular. That's the plan, because it's easier to work in polar. Does that make sense? So we don't want to do all that we just had to do there, and I went quick in big messy numbers and saw some shortcuts. That's as good as it's ever going to get to do it all by hand. It's easier. Step 1, change to polar. because it's easier to do the powers in polar. De Moivre's theorem lets us do it a quick, easy way. So we got to change that to polar. How do we change to polar? Well, if you look back at the instructions for that, here they are right here. That's number 7. Changing rectangular form to polar form. Here, I'll bring that one over as well. That's a earlier instructions, which I'll put right here for you. There it is. How do we change rectangular form to polar? Step 1, plot the point to see which quadrant it is in and calculate R. So first off, we got to plot the thing. Let's do that over here. So there's a little axis system. We're going to plot this point. It is, this is like the X and the Y, right? So it's back 1, down 1, 2, 3, 4, 5. It's right there. That's the number back 1 minus 5i. Remember, this is the x-axis is the real axis, and the y-axis is the imaginary axis in the complex plane. So it's back 1, down 5i. So there it is. And if you want to know, so it's back 1, down 5i, you want to know the length, r, there it is, that's the length right here of that complex number. It's a little triangle, isn't it? Back 1, down 5. So you just do the r is the square root of x squared plus y squared. That's what the formula says right here. Calculate the length of the polar number. Square root of x squared, negative 1 squared plus y squared, negative 5 squared. So r is the square root of 1 plus 25. R is the square root of 26. Okay, square root of 26. I'm just going to leave it like that for now. Square root of 26. I don't want to get a decimal yet. Square root of 26. Okay, so now that's step 1. And then for the angle, you find the reference angle theta is the inverse tangent of the absolute value y over x. And then you got to change that into an actual angle with the quadrant stuff. Remember that? So let's do that. So the reference angle theta is inverse tangent of y over x of absolute value y over absolute value of x. So that's inverse tangent. What's y and x here? Well, this is y, negative 5, and x is negative 1. So we go positive 5 over positive 1, right? Absolute value makes them positive. You know that. So, and so that'll be what on the calculator? Inverse tangent of 5. Make sure you're in degree mode. I'm getting 78.6900,675 degrees. I use a lot of decimals right now. But that's just the reference angle. That's not the actual angle. Remember, this is the reference angle. To find the actual angle, you got to realize your quadrant and then use these formulas. What quadrant are we in here? That's why we graphed it in the beginning. Third quadrant. So in the third quadrant, quadrant 3, the actual angle is 180 or pi, depending on whether you're degrees or radians, plus the reference. So the actual angle is 180 plus that reference, 78.6900,675 degrees. So the actual angle theta, use my calculator, add 180, 258.6900,675 degrees. That makes sense. We're in the third quadrant, right? We're almost at 270 degrees straight down. So that makes sense. That's the actual angle. So now, to finish the polar form then, remember polar form is r cosine theta plus I sine theta. So now we've got our r. R is right here. Square root of 26. Just leave it that way for now. Square root of 26 times the cosine of that angle, 258.6900,675 degrees, plus I sine of that very same angle, 258. I'm going to go dot, dot, dot. All right, so that's step 1. Change it to polar. All right, step number 2, power it. So how do we power it? Well, what power was it? It was the 6th power. So we're going to take that thing to the 6th power. And what did de Moivre's theorem say? You just power the number in the front, so it's right on down here if you want to see it. How do you power it? You just power the number in the front, right? I referred us to number 10 above. Power the number in the front, multiply the angle. So power the number in the front, multiply the angle. So I'm going to power the number in the front. So here we go. It's going to be the root of 26 to the 6th power. And then multiply these angles. So just use your calculator. Multiply 258, that thing you get in your calculator, times 6. It's not to the power 6. It's times 6. I'm getting 1552.14, that's close enough degrees, plus I sine same. 1552.14 degrees. All right? And then it says, down here in the instructions, step 2, power it. Step 3, change it back to rectangular by distributing the number in the front. So now we just take that number in the front. Oh, what is square root of 26 to the 6th power? Take your calculator, take square root of 26 to the 6th power, and you'll get a nice clean. Don't put in a decimal. Do exactly what it says. Square root of 26 to the 6th power. You'll get 17,576. Distribute that, bonk, bonk, times the cosine of 1552.14 degrees plus that same number, 17,576, times the sine of 1552.14 degrees. Oh, I forgot the I. Here's the I right there. So let me bring down the I. Like that. All right. Times the cosine 155.2.14 degrees. It's fine to have this big angle. We don't need to change it to anything. I'm getting minus 6623 point. How many decimal places do they want? I don't think they said on this one. Okay, minus 6623.88 plus 17,576 times the sine of 155.2.14 degrees. I'm getting 16,280.05 I. So there it is. Now, how did it come out compared to the other one we got? 6624, 6623, yeah, 6623.88. And 16,280, 16,280. So it came out very close. Because of our rounding, it did not come out exactly right. So really we should round those to the nearest whole number. So that would round to minus 6624, and that would round to 16,280, and that's the exact same answer I got the other way. Now you might say that other way was actually easier, Mr. Heron. Well, yeah, I did a couple of tricks. I promise you that some of these they're going to give you like 10th power. And then no way is this little trick stuff I did. You're not going to want to foil these 10 times or even 5 times, and then it will eventually. This polar method is quicker. It's not simple, but you can even do 100th power, which you would never want to do with 100 foils with any tricks. So you see how it came out the same, except for that little rounding, and that's because of the fact that I did round. Even my number, I took it pretty far, but I rounded a little bit. So you want to use a lot of decimal places of accuracy, and then in the end, just round to the whole number, because that's actually exactly what it is when you round in the end, because it got thrown off a little bit because I rounded halfway. Even though I went 6-7 places, it was rounded a little bit, and so that threw it off a little bit. So if you can, use the whole number, the whole angle on your calculator, and it should come out exact if you do that. So maybe I'll go back and say, how would you do that? What am I talking about? Right here we do the tangent inverse of 5. Tangent inverse of 5. when you get that 78 thing on your calculator, you add 180 to it. Just leave the exact value on your calculator, and then hit the cosine of that times the root of 26 to the 6th power, and let me see. Am I getting the exact value? I don't think I am. What did I do wrong there? Yeah. So let me try it again. So tangent inverse of the 5, you get that 78. We add 180. We get that right there, and then we take the cosine of that times that, and we get our exact answer.